This is the first video of our M3 module for GCSE Mathematics. We're going to start with doing a bit of basic recap from basic number stuff that you should know from your previous years in school. So the first thing we're going to look at is properties of numbers. And the first thing is integer. What is an integer? So if you underline this first bit, an integer is a whole number. So for example, an integer could be 8, 9, 10, maybe a minus 5, -4, -3. Okay, so there's just 6 examples of integers which are whole numbers. Okay, next thing we're going to look at is factors. So a factor is a number which will divide into another one, and the number 2, for example, is a factor of 12, since 2 will divide into exactly into 12. There are a limited number of possible factors for any number. So the number 12 may be expressed as a product of two factors in 3 different ways. So 1 times 12, 2 times 6, 3 times 4. So you would say the factors of 12 factors of 12 are, and it's just nice to write them in ascending order. 1 was the first one, the lowest one, then 2, then 3, then 4, then 6, then 12. Okay, I'm going to give you another one here. If they said to you to find the factors of 24, it's easy, very easy to miss any, so a good way to do it would be to just go through how you can get 24 as a product. Product means when you what you get when you multiply two things together. So the easiest one is 1. So 1 times 24 will give you 24. Then the next number I try would be 2, and 2 times 12 gives me 24. The next one I would try would be 3. 3 times 8 gives me 24. Next one would be 4. 4 times 6 gives me 24. And the next one then would be next number 5 would go into it. Next number would be 6. 6 times 4. And notice I've repeated myself here because these two are the same. So we can get rid of that last one. And if I went on any further, I'd just keep repeating myself. So here I have found the factors of 24. So let's just write that in. I'll do that, separate that a wee bit, and we'll just write that in here. Factors of 24. So I've found all the possible ways you can multiply two numbers together to get 24. So the factors of 24 are, and again, like we did in the previous example, write the lowest one first, which was 1, then we had 2, then we had 3, then we had 4, then we had 6, then we had 8, then we had 12, and 24. So the two most common ones that people would forget here would be 1 and 24. So key thing here, 1 is a factor of any integer, of any whole number, and the number itself is going to be a factor. So here, for example, in this one, when we were looking at our factors of 12, 1 was a factor, and 12 was a factor. Okay, we're going to look at multiples. So a multiple of a number is, a multiple of a number is that number multiplied by an integer. So the multiples are used in the times tables. We cannot list all the multiples of a number as they go on forever. So multiples should be larger than or equal to the original number. So a multiple is always going to be bigger. Okay, so what I mean by that, I should say, if we look at our multiples of 4, for example, the first one is 4. It was 4 times 1. The next one is going to be 4 times 2, which is going to be 8. Then 4 times 3, which is 12. 4 times 4, which is 16. 4 times 5, which is 25. 4 times 6, which is 24. And we can go on forever. So we go on beyond our 4 times 10 or 4 times 12. It goes on forever and ever and ever. Okay, right, we're going to get rid of that, sorry. And in this example, it says, write down the multiples of 6 between 35 and 50. So in a question, I guess what you're really doing is you're thinking, what are my times tables answers, I suppose, whenever I go through my 6 times tables. So let's just go through. We'll write down a few of them. We've got 6, and then we'll be writing these down and then just getting rid of them here for you. So 6 is the first one, and 12, that's 2 times 6, then 3 times 6, 4 times 6, 5 times 6, 6 times 6, 7 times 6, 8 times 6, 9 times 6, and then we'll go 10 times 6. Now you wouldn't have to do this. This is just for me to show you this. And then what you can see, the numbers or the multiples of 6 which are between 35 and 50 would be this one, and this one. So the rest of them we can just get rid of, which is easier said than done, but we get rid of them and see what we are left with. So you're left with just clearly 36 42, and 48. Okay, next thing is prime numbers, and very soon we'll be looking at a combination of prime numbers and factors, which are called prime factors, but at the minute just prime numbers. So a prime number is a number that can only be divided by itself and 1, i.e. it has only 2 factors. So the 2 factors must be different. So that means 1 is not a prime number. So why that is, if you think about 1, the only way you can get 1 is 1 times 1, so it's got a factor 1, but they're not different. So that is not prime. Okay, so the first prime number is 2. The first prime number is 2, so just add that in. That's important and it's worth having in. First prime number is 2. Okay, and that is because 2, the only way you can write 2 is 2 times 1, and that's it. Okay, next one, it says the 2 factors must be different. This means that 1 is not a prime number, and then I've given you an example here as well of 13. 13 is a prime number. Its factors are 13 and 1. There's nothing else. Okay, very important, and it's worth your while to learn the first few prime numbers. So we're going to go through them. Okay, we said already our first prime number was 2. We have to list the first 8 of them, so that's 1. That's the first one. The next prime number, just go to your next number, 3, and think what divides into 3, and it's only 1 and 3, so it's self and number, self and 1. Let's go to 4. Okay, 4 can be divisible by 1, 4 can be divisible by 4, but 4 can also be divisible by 2, so 4 is not a prime number. So basically, way we can make this easy for ourselves, well, I don't know why it's not rubbing that out, way we can make this easy for ourselves, folks, is any even number except 2 will not be prime. So we'll move on to the next one. Our next one is 5. Next number was 5. And 5 can only be divided by itself and 1, so 5 is a prime number. 6 is the next number. We've just said even numbers aren't going to be prime unless it's 2. We'll move past 6 on to 7. And 7 can only be divided by itself and 1. 8 is the next number, but 8 is an even number, so not prime. Next number is 9. 9 can be divided by itself. It can be divided by 1, but it can also be divided by 3, so 9 is not prime. 10 is an even number, so that's not a prime number. The next number we get to is 11. 11 can be divided by 1, and it can be divided by 11, and that's it. So that's as good as we need to go. 12 is even, forget about it. 13, they've even said in the question it's prime. And next one is 14, forget about it. 15 can be divided by 1, can be divided by itself. It can also be divided by 3 and 5, so 15 is definitely not prime. 16 is even, so it's not prime. 17 is prime because it can only be divided by itself and 1. Let's just count up how many we've got here. 1, 2, 3, 4, 5, 6, 7. One more to go. Next number is 18. 18 is even, so it's definitely not prime. The next number is 19, and 19 is prime as 19 can only be divided by itself and 1. So there you have it. I've got my first 8 prime numbers. Okay, this thing here is just about indices. We're doing it. We will see this in more detail later on in the year, but for the time being, we'll need this because we'll need this for what we're doing later on, prime factors. But it's just saying the shorthand way of writing 2 times 2 times 2 times 2 is 2 to the power of 4, you would read. That's because you have 2 multiplied by itself 4 times. That's why it's called. The 4 is called the index or the power, and 2 is called the base, and we cannot mix different base numbers. We're going to look at these ones here, and it says 2 times 3 times 2 times 5 times 3 in index form. So what I would do if I was doing this one, first thing I would do is I would rewrite the thing, making it a little bit different. It looks a bit different, but it's the same. So all I've done, I've changed the order of the numbers here. So instead of 2 times 3 times 2, I've changed it to 2 times 2 times 3 times 3 times 5. And then what I can do is I can group these two things together. So they can just become a 2 squared. These two things can be grouped together. They can become a 3 squared. And then I'm just left with 5. And I'll just say this is in index form. Okay, part B, a wee bit different. You can do this whatever way you want. And I would write this out the long way. That's 3 squared times 5 squared. So 3 times 3 times 5 times 5. Because remember, 3 squared means 3 multiplied by itself twice. 5 squared means 5 multiplied by itself twice. So 3 times 3 times 5 times 5. I'm just going to multiply the first two numbers together. Give me 9. I'm going to multiply the second two, or the last two numbers, I should say, together. Give me 25. And then I've got 9 times 25. Okay. My number skills aren't great, so I'm going to show my working out to do this. So I'm going to do, over the side, I'm going to do 9 times the 5, which gives me 45. And then 9 times 2 gives me 18. Plus the 2, so the 4, sorry, from the 45 gives me 22. So 9 times 25 is 225. Okay, our last page we're going to do here today is on Venn diagrams. A Venn diagram is a way in which we can present data. We use a rectangle to show all of the data and the circles to show all the data in a particular category. We show data that belongs to two or more different categories in intersections of a circle. So our first example, I've already done a bit of the Venn diagram for us here. It says 24 pupils are in a class. 10 of them are in Delta House, 5 of them are in Tango House. Show this on a Venn diagram. Okay, there's no overlap in these circles. These are two separate circles. The reason for this is there's nobody that's in Delta House, which is also in Tango House. So I've just said D for my Delta House, and I had 10 people. I said 5 for my Tango House, and I had, sorry, T for my Tango House, and I had 5 people. What we're left to find here is this bit. How many's in here? So how we're going to get this number? So these are people who are not in Delta House and not in Tango House. So I'm just going to do my 5 plus my 10, and that gives me 15. And then I'm going to do my 24, minus my 15. Because there are 24 people in total in this class, remember? So take the 24 minus the 15 is just going to give you 9. So that's how we get it. You could check out again at the end. You could do your 9 plus your 5 is 14 plus the 10 gives you 24. So you've got all 24 people in the class accounted for. Okay, good bit trickier this one. This one said there are 104 pupils in year 11, 50 study geography, 44 study history, and 15 study both subjects. Show this on a Venn diagram. Right, start here. So start with both. I'm going to write that differently. I'm going to say start with the overlap, because that will make sense for the next example as well. Start with the overlap. So the overlap was 15. There are 15 people who studied both subjects. That means in here, if I can squeeze this in, it's a wee 15 in here because there's 15 people in this wee bit. The next bit, and we work back. The next thing was this thing here was 44 study history. So this 15 plus this number have to add up to 44. So I'm going to show my working out on this one. I'll not be doing this on the next one because it gets far too messy. This is going to be 44 minus 15, which equals, and I've just got my calculator right here, 44 minus 15 is equal to 29. Okay, likewise, it says 50 study geography. So this whole circle must be 50. So in here, that's going to be 50 minus 15. So just write again, I'm showing my working out for this one. 50 minus 15. And if you do 50 minus 15, you get 35. Okay, the only thing we're left to find is the bit, these are for people who aren't in geography, aren't in history, or aren't in both. So we want to find the remainder. So it's going to be 104 minus those three numbers we've now got in our circles. 35 minus 15 minus 29. And press equals, and I'm just going to do that in the calculator. 104 minus 35 minus 15 minus 29 equals, and I got 25 when I punched that into the calculator. So 25. Okay. Okay, this last example, there are 130 tourists from a cruise ship visiting Northern Ireland. 42 visit Giant's Causeway, 52 visit Omagh History Park, 50 visit the Titanic Quarter, 14 visit the Giant's Causeway and Omagh History Park, 12 visit the Giant's Causeway and Titanic Quarter, 10 visit Omagh History Park and Titanic Quarter, and 7 visit all three this is incredibly complicated if you let it be. It says in this question to show this data on a Venn diagram. You can see I've done this in a more of a square than a rectangle nearly. And I've got GC, which stands for Giant's Causeway, OHP, which stands for Omagh History Park, and TQ, which stands for Titanic Quarter. Now, what we want to do here in this one is start with all three. So I'm not going to write start with all three. I'm going to say start with overlap. Now, it would be useful for you to, when you're going through this, to watch this video again. We start with the overlap. So why it would be useful for you to watch this again? You'll not remember where all these things come from. So when you're looking at your notes, it'll just look like a series of numbers written on this thing, and it's definitely not that. It's a wee bit more complicated. So 7 visit all 3, so that's what we want to start with. So put that in the bit that is overlapping in all three circles. So in here, that's going to be 7, and then we're going to work back. So we're going to work back reverse order here. In this, it said the next thing, it says 10 visit Omagh History Park and Titanic Quarter. So there's Titanic Quarter and Omagh History Park. These two numbers have to add up to 10, so it's dead easy. 7 plus 3 gives you 10, so this must be a 3 in here. Go back to the next bit. It says 12 visit Giant's Causeway and Titanic Quarter. So Giant's Causeway and Titanic Quarter was this overlap here, it's sort of oval, and that was 12. So 7 plus 5 gives you the 12. And then next one, it says 14 visit Giant's Causeway and Omagh History Park. So that's 14 for Giant's Causeway and Omagh History Park. So 7 plus another 7 gives you the 14. And then we're on to the single ones. So the single ones, it says 50 visit Titanic Quarter. So these three numbers plus this one in here have to add to be 50. So just do a wee bit of working out for your Titanic Quarter one. So what I'm doing on my calculator, and I would use my calculator for this. Oops. Well, you would use my calculator for this just to check I'm right and to make life a lot easier. So it's going to be, it was 50 minus 5 minus 7 minus 3 is equal to, and it's just going to be 35. Okay, so it's a very easy sum, but just do it on your calculator just to check. Next one is your 52 visit Omagh History Park. So this number here plus the 7, 7 and 3 must be 52. So on your calculator for this one, you're going to do 52 minus 7 minus 7 minus 3 and press equals. That's going to be 49. And almost there, we've got 42 visit the Giant's Causeway. So 42 is going to be this whole thing. So that's this missing number plus 7 plus 7 plus 5. So to get this number in here, it's going to be 42 minus 7 minus 7 minus 5, which is going to give you 23. Right. The last thing for us to do is to find what is left outside. So this is the tricky bit. So to get this number here, you're going to have to do, there was a total of 130 people. So it's 130 minus all these numbers. So 130 on my calculator, I'm typing in 130 minus 23 minus the 7 minus the 49 minus the 3 minus the 7 minus the 5 minus the 35. And I have got one poor soul who didn't go to anything at all. Then answer your questions and stop. Answer your questions. B, how many did not visit Titanic Quarter? So sorry, some technical difficulties here with the pen, but how many did not visit the Titanic Quarter? So for this one, for the Titanic Quarter, it's going to be, I'll just do 23. Not visiting the Titanic Quarter is 23 plus 7 plus 7 plus 49 plus 1, and whatever that all adds up to. So just add those up, 23 plus 7 plus oh, sorry, that 7 shouldn't be there. Get rid of one of those 7s. 23 plus 7 plus 49 plus 1. And that's it. So 80 people did not visit the Titanic Quarter. And it says how many people visited only 2 places. So the people who only visited 2 places, these 7 only visited 2, these 5 only visited 2, and these 3 only visited 2. These ones in the middle visited all 3, remember. So it's just going to be 7 plus 3 plus 5, which is 15. And that's us done.